Let us begin building our trigonometric knowledge of complex numbers. So everything we've done so far, has all been algebra. Z is equal to a plus bi. Z is equal to -2 minus 3i. Yeah, dude, that's algebra. We just reviewed. We're just getting ready so we can start taking all this algebra and start turning it into trig. So if you don't mind, I'm just going to place this random thing. C is equal to a plus bi. You don't like the a's and the b's, change the a to 2 and the b to 3. You know, and I'm just gonna place it right here. I'm gonna put it in the first quadrant. Could put it in the second or the third or the fourth quadrant. It doesn't really make any difference, but I think just for understanding, it's gonna be easier for us to keep it just right there in the first. And what that means is we have the real portion, that a. So this must be a down here, and then the height up here, that must be b that was attached to our imaginary portion. Cool? Cool. So, and you're like, I thought we were doing trig, but we draw shit, right? We draw triangles in trig, don't we? We draw triangles in trig. So if we want to take something from algebra and you want to turn it into trig, go plot some points and then start turning some things into, triangles. So let's draw ourselves a line. I'll probably get something squiggly, but there it goes. So there's a line out to it. And remember this, how we said that this is like that little magnitude thing? Well, your book kind of switches up the notation. We got to talk about this. That we can also call it R. And if we forgot that this is just equal to the absolute value. Remember the distance. That's the distance back to the origin. Distance to origin. There we go. All right. So just knowing that it's called R, it's going to help us out a little bit. So now we have the hypotenuse of our right triangle because, boom, we're just going to draw it in as a triangle. I'll move the Z out of there so we can remove some noise, but we can say that our height is B, right? See, the height is B. And then we can say that that A on the real portion, or the horizontal distance, that's A. So we have an A squared plus B squared is equal to R squared. We use that for radius. We're going to also use that term when we go into polar. So knowing that the hypotenuse known as R is helpful. And in these terms, this R is always positive. All right. I think we have some things set up. Since this is trig, don't we need an angle. And what's beautiful is we can make our angle right in here. And we're still going to think of everything as this is being 0 and 2 pi. This is being pi over 2. This is being pi. This being 3 pi over 2. It goes in the same direction. Everything. So you can be in the third, fourth, second quadrant. It still all works. So let's start solving for things. Like I want to know what A is. And I want to know what B is in terms of trig stuff. So if you don't mind, let's start with A and R. We'll put those two together. So we say the adjacent and the hypotenuse. The adjacent and the hypotenuse, that's cosine. So cosine of theta is equal to our A over our R, or the adjacent over the hypotenuse. All right, so now we're going to solve for A just by multiplying over R. We're going to find out that A is equal to R times cosine of theta. Now we're going to play that same game, and we're going to do it with the B and the R, and that's going to be sine, right? So we could say that sine of theta is equal to the opposite B over R, the hypotenuse. You move it around, and you find out that B is equal to R times sine of theta. Here we go. There's A. There's B. And here we are. Let's put it in. We can say that Z is equal to, instead of writing in A, we're going to write R times cosine of theta plus, now I'm going to make a parenthesis because there's going to be an I at the end of this, right? We're replacing in for B. We put in our R sine of theta. Now what ends up happening here is we have something in common. We have an R on both terms. An R on both terms telling us that we're going to have, we can pull this out to the front. And this is a little strange. We're going to write the I in front of the sign. Usually we write sine theta I, but we like the I in front of that. It's just a traditional way that we're going to write it. And here it is. Here's our trigonometric way of writing a complex number. It tells us the angle, right? That theta in which we're pointing. And then this R here, this big R right there, that is describing how far away we're going to go. So all this is doing is saying, hey, how far and in what direction? How far and in what direction? So as long as we can tell it how far to go and what direction, we can figure out both the A and the B. And now this is where, for me as a nerd, I think it becomes fun. It's a puzzle going back and forth. Now here's your book's way of writing it. Where we get it all, where we say that Z is equal to A plus BI, we can also write it in the way we just showed. But as we continue to look inside of here, it says that A is equal to R cosine of theta, B is equal to R sine of theta, and that A squared plus B squared equals C squared. And then there's going to be a tricky game, which we'll discuss in another one, where I don't like the way they write this. They leave some ambiguity, because we're going to play this game in the opposite direction, where we went from algebra to trig, but going from trig back to algebra has a couple of little pitfalls. And that has to do with solving for the angle and having to use inverse trigonometry in order to solve for these things, which we're going to need to know our quadrants. But with just a little bit of mindfulness in future videos, we're not going to have any real issue with it. So here is your book's way of writing it out with all the important stuff that you're going to need. And we're going to start just taking it. We'll play another game like this in a future video. And we will play a couple of other ones through here before we get to Old Demois. So we'll talk soon.